psychiatrist, but social scientists with a strong interest in the motivational factors behind suicide and some of the theoretical perspectives on the type of language that people generally use if seen in kind of one-to-one appointments. And it came out that there would be typically strong emotions. Things like anger, general aggressiveness are typically prominent in one-to-one discussions. So we used that kind of theoretically informed perspective to try and map tweets onto affective domains. We used the word affect domain, which essentially can represent things like fear, anxiety, and then more broad things like levity, gaiety, and happiness, and so on, to see whether they would actually help us in distinguishing between different types of suicidal communication. And the third thing we did was to actually start looking at other social networks and seeing if we could draw on clues from those to help us classify tweets. So we actually looked at Tumblr for this. So Tumblr has a very big community around suicidal methods, very, very graphical, very image-based, but also with the text narrative as well. So we collected tweets and we collected Tumblr posts. We got both human annotated with a coding frame that I showed just now. And we used a Tumblr post to kind of cross-pollinate the features that we were using to try and annotate classify the Twitter posts. So there were a lot of features, and we ended up with 1,400 plus features because of all the different emotions that could be in there. So we reduced these as well using principal component analysis. The main motivation behind that was to try and see what terms were clustering together to be explanatory of particular types of language we were trying to classify. In doing so, I came across a method that actually breaks the data set down in training and builds principal components for each chunk of the data set, called a rotation forest. So whereas using principal components as a training method for classification of text, we tend to do that once building principal components and use them as a classification feature. Whereas the rotation forest approach actually takes the data set, chunks it up, builds principal components for each chunk, and then uses those in training. So you get more diversity in the training features, which is quite interesting. So we integrated that as well. So you can see from this is results for all classes, and there really wasn't much difference between the different classifiers. So we've got a kind of a Bayesian probabilistic approach, a decision tree approach, and using a support vector machine. Just to try and see if there is much variance between them and see if the way of making the decision made any difference using these features. It really didn't so much at the high level, and feature sets themselves also didn't really make a huge amount of difference for all classes. The rotation forest, which actually chunks the text up, training set up, and uses it to build a number of principal components, actually did improve significantly over just using all the features individually, which was very interesting because it showed us capturing some of the variation across the language. And we ended up with fairly reasonable results. So this is the average of all different types. So if we actually look a little bit at the target class that we wanted to identify here, the suicidal ideation, we start to see some variation both across the feature sets. So set 1 being the standard barrel words, parts of speech, set 2 being the more affective and emotional stuff, and set 3 being the clues, if you like, with brought in from Tumblr posts, and then the combined setting incorporating all of these. Again, the rotation forest works best, but what we're seeing is that there are perhaps more probabilistic features that are occurring here. So we looked a little bit at the text that was evident in the suicidal class, and I can show you in a minute why these were probably occurring more probabilistically. But again, we've got a very reasonable result here to try and identify suicidal ideation. Given that this wasn't a binary, all our other classes have really been a binary or maybe a three class classification. We had 7 classes here to classify into, which is quite tricky. We were quite pleased with these results. So what we found was that the word lists, so the regular expressions extracted from some of the Tumblr posts, were actually prevalent in the Twitter posts and were actually very useful in that particular set of classifying suicidal ideation and and intent, which is good, because it at least shows that across social networks this is kind of working to represent how people are self-reporting in this way. The lexical and grammatical bag of words type approach and the parts of speech and so on weren't particularly effective at all, which suggests they were appearing across all different classes. Which is good in a way. I mean, that was something that we wanted to see. We really wanted to see that we could distinguish language types in different ways other than just using a standard bag of words. And the effective language using the WordNet set of cognitive synonyms was very good, especially at the suicidal intent language, which kind of confirmed what we'd expect theoretically, which is that some of the particular emotions were highly present in the suicidal ideation text and helped in the classification problem, which was great. Sentiment analysis we included again, and as in our previous studies, we found that it actually wasn't that useful at all. Being positive or negative really didn't make a whole lot of difference when it comes to classifying this type of text. So I included in here, it's not very pretty to look at, but these are some of the principal components for the possible suicidal intent. And I just really wanted to show the presence of some of the affective stuff here. So essentially the positive symbol here followed by something shows a weighting and a positive association with it belonging to that particular class. Negative stuff, less likely to belong to the class again with a particular weight. And what we're seeing is things like alarm and adverbs and superlatives. Also, where's it gone now? There was another one in there as well, I can't see it right now. But you can see also the words, regular expressions that are coming through in there. Misery is the other one I was looking at. And then we've also got stuff that detracts from suicidal intent, so where people are expressing admiration and security suggests it actually belongs to a different class. So given that language changes over time, what we wanted to try and achieve is to use some kind of well-defined structure, such as affective states, whereby as language changes over time, we can incorporate those particular words as they evolve into this taxonomy of how people are feeling and how they're expressing their feelings, so that as language changes, at least the model may stay fairly similar in terms of people's emotional states, and the words can be mapped onto that so that this can continually be refreshed. So it was good to see those kinds of things coming through. So finally then, we wanted to actually see if we could use this data that we classified to identify communities. So it varied between the various project members. Some people thought they'd be very dispersed, isolated, wouldn't really connect themselves in a social network. Other people thought that social networks may actually provide a place for people to connect around this. So what this social network graph represents is communities of people, particularly expressing a suicidal intent class. And this isn't actually based on the machine classification. This is based on the human classification. So it's kind of as close as we're going to get to a realistic social network of suicidal users. And what we can see is that there is a very strong connection between people, suggesting perhaps friendships, online accounts that are forming a community of interest around suicidal ideation and intent. There are obviously lots of people who are one-to-one relationships, but this central focus here, and you can even see that there are several key actors who are prominent and influential in that particular domain. You have a lot of people following them. And if we look at how information suicidal intent propagates through social networks, this graph shows green lines is no follower relationship, but a retweet. And the red lines show that there is a follower relationship and a retweet. And what we can see here is that actually within a large part of the social network, there's no follower relationship here. People are seeking this out, retweeting the information to their followers, and then you've got your kind of weak tie bridges in the middle as well, which are actually allowing information to propagate from here over to here. So there is some evidence, I suppose, of some virality of this spread, not necessarily from a well-formed community, but that people are using this kind of online social network to explore the content and propagate it to other people that they follow. This was also supported quantitatively through the analysis of a number of open large-scale network data sets, which showed the average shortest path between nodes in the network. So, I'm trying to think off the top of my head, I believe it was around 2 point something. This is the average shortest path in other baseline large-scale networks, and in this particular study it was around 5. So it's suggesting that in comparison to that, this information is propagating significantly more than it does in other examples of large-scale networks. So again, there is evidence to support that this perhaps propagates more than some other material. Okay, that's me. I hope that was useful and take some questions.
So let's thank the speaker first.
So at the beginning you were talking about multidisciplinary aspects to the research,
Yeah.
and you mentioned working with criminologists, etc. So the question I had really was, how do you ground the machine processed analysis with the sorts of analyses that the other disciplines might do, the qualitative thinking, etc.
Yeah.
Did you bring those things together?
We did actually, and I should have actually put some of the slides in, but for example, I'll give you an example of the cyber hate speech stuff. And what we actually did there was to take chunks of time and look at how people were making sense of the events over time. So it was grounded in criminological theory, so Cohen's theory of moral panics and how people make sense of things in a kind of, so typically there's a warning phase, obviously didn't have the warning phase, but in the immediate aftermath, going into reaction, and then in the follow-up in the later weeks, how people start to make sense of the event and name the victims, name the perpetrators and so on. And then we'll find later on, in the later stages, that people move away from the victim and the perpetrator, start going back up to general topics such as immigration and war and that kind of stuff. So I should have put those in because they're really interesting, and we actually visualised that in Cosmos as well. So we were able to show geographically how the response changed. So it started off obviously in central London, then spread to Manchester, which was Eureka's home, and then spread out across the larger cities. And then as the time went on towards the 2 weeks, it was very much more dispersed, and people were talking about it across the country and in a more general way. So that was how we worked, and that actually worked quite well. It did explain it. There was definite time windows where the kind of text changed from one to the other. I think it was first 24 hours was when all the confusion was there, and then after that it started trying to make sense of it, and then it was, I think, in the last 2 days, so 12 days on, it started to revert to the general topics.
Is there any sort of risk or theory around the fact that you're capturing data from a very specific channel like Twitter, and you're generalising from Twitter data? I mean, is it well understood, for example, what sort of people use Twitter? Or is it just assumed it's a general population?
No, we've done some research into that actually. We found that Twitter is used generally by 15 to 25-year-olds. It's also used generally by people in kind of middle-level management and kind of above positions by mapping their occupation they specify in their profile description onto UK SOC codes and all to represent the job that they do, and how that maps onto some kind of theoretical class, social class, I guess. So yeah, generally it's those, but there are also a lot of the other types. Still, the age is very, it spikes at 15 to 25, but there is a very large population right across the board from 15 to 85 plus of people that use it. And I suppose really around a particular event, we've done this study generally, we haven't done it around a particular event, so it's a good research question whether we can repeat that in an event and see what sort of people are reporting on it. So there is obviously bias there. I don't know how much you can generalise from it. Like I said, I think it's really an event-specific measure, insight into what people are saying online. It doesn't necessarily represent at all what they feel offline. This is essentially what people are saying online. But there's a lot of research that people tend to go to Twitter to talk about themselves and what they're feeling and what their views are. So I guess there is some established literature to suggest that what they're saying is some kind of reflection of what they feel. With regard to bias, in terms of how to use that as information, that's an ongoing problem. Working with.
And I guess what I was, the sort of thing I was thinking of is if you see a car crash or something, there's some sort of people just walk away from it, and other people get their phones out and start taking photographs.
Yes.
So
So who does that?
Yeah, precisely. So,
no, actually, not that I'm aware of at the moment. So a colleague of mine in Cardiff is doing some work on trying to establish who turns their geolocation on. But regarding who actually comments on an event, no, but it would be actually a really interesting study to be able to do that.
do you think there's any potential? Is there any potential for looking at the data? I can't remember how tweets work. You get user tags.
Yes, the main way to identify, I guess, any kind of demographic information is from the profile description that you get with part of the tweet. So the tweeter's profile information contains often their occupation, sometimes their age, where they live, some of their interests. So there's definite, textual analysis that can be done on that to work out. I guess all you're getting there is who does tweet. You don't know who's seen it and who hasn't tweeted. But it would be an interesting study. There's definite potential to try and work out if there is some kind of pattern across events to allow you to gain some insight into that. Yeah, definitely. Yep.
I was particularly let's say, surprised by a slide on the cyber hate where the likelihood of...
Oh, yeah.
Yeah, I don't know if you can... Well, we can talk about it, and it's not on the screen. Thank you for bringing that up. Yeah. So, to some extent, I was wondering whether sort of bigger, more theoretical explanations can apply. So, what's your view on this? As I said, it sounds surprising to me because some of these are sort of just like crowd-based dynamics where maybe discourse is opaque. I haven't done any specific work as you've done on full discourses, but as I've seen a little bit around on Twitter, but not just on Twitter, they just kind of self-fuel themselves sometimes.
Yeah.
So I found it quite striking.
You mean particularly the cyber hate part?
Yeah.
Yeah.
And it sounds relatively more, let's say, expectable for me what you show in the next slide.
Which is the narrative.
Yeah, the fact that it dies quite quickly
Yeah.
sounds fair enough to me, but the fact that it has a sort of increased, slightly less likely to be...
Well, even much less likely. It was around 45% less likely, which was significantly less.
It's very significant.
Our theoretical interpretation of that, we've got an ongoing project around governance on social media because it's very underdeveloped. It's not really that. You have those reporting mechanisms and so on that people are discussing. How do you police it? How do you govern it? Should you police it? Should you govern it? And we've got a project looking at how interactions occur and whether that plays any role in kind of dispelling rumour or stemming hate speech. That's kind of ongoing, but the result of this was essentially we figure people are self-governing. So you may see the cyber hate, but you're not actually propagating it. So it's almost like a lack of interaction with that, and a lack of propagation is a kind of self-regulation, and I guess community regulation as well, because it's not being propagated. Our hypothesis was that it would be more likely to propagate.
That's why I asked it.
Which was strange, and it was a large data set as well. It was just like 450,000 tweets in here, so. There shouldn't be any small n problem. It was statistically significant to 0.001. Not that matters, but it was a statistically significant finding and very surprising. And you know, the fact that all the others go the other way as well is
Yeah.
I mean, this kind of makes sense. You've got a media presence, you've got a police presence, yeah, okay, that's fine, that makes sense. The stuff on hashtag and URL, well, you've got evidence-based, so if you've got a URL, it's more likely to be retweeted because there's evidence in there. Hashtag makes it more discoverable, so if people are following the event, yeah, okay, that makes sense, there's going to be...
Yeah.
And you know, the Google searches, so Google searches mean that people are looking for additional information about the event, so it would make sense that there'd be more propagation on Twitter. So the rest of the model is fairly logical, so there's no reason to assume that there's any issue with the cyber hate. We just need to find out kind of some kind of explanation for why that is occurring. At the moment, it's self-regulation.
My kind of just observation. My first, in reaction to this was, well, maybe it is just that simply, logically, people don't want to be associated to cyber hate in the long run, and they kind of are, self-regulating on a sociological kind of point. They don't really.
Yeah, I mean,
really keen to be
you've got your follow relationships, so you have your own community on there, and as much as people say social media is about anonymization, it's not really. People that follow you know who you are, and yeah, you may not want to be associated with propagating that kind of information, even if you do support it or feed it.
Seems to me you'd need to do a comparison with other events to see whether this was just an aberrant factor that was to do with the particular event and how people were relating to it.
I mean, that's the plan essentially, is to do, we need a comparative event obviously to compare it to, but yeah, the plan would be to build this. I mean, what we're doing at the moment is looking at, so this was cyber hate, particularly with a religious or racial aspect. We're rebuilding the model on data sets that include other protective characteristics to see if the features are predictive, if type dependencies work in the same way, and we can also rebuild the models on other events that include different types of hate speech. So they wouldn't be the same, so it may vary anyway. It may be that the type of hate speech doesn't impact on whether it's propagated or not.
Are you doing any on gender hate speech?
Yes, we got a data set from the Carolina Perez case. The Nun's Note.
Okay, do you have something interested in talking to you about that?
Yeah, great.
So if I'm not wrong, when you extract the JSON format from a tweet, you don't get any information about the network of the user.
That's right, yeah, we had to manually build that.
So that was my question. Do you
To gauge.
cross-check against the network of whatever tweet you are...
Yeah, so we took all the tweeters, identified all of the handles of those tweeters, and then carefully constructed a query to go back to Twitter to get all their followers and friends, because there's a rating on that.
So this means that you are in fact able to say, not, to qualify the propagation value in terms of, yes, if this tweet has been retweeted to a network up to so many nodes, rather than a smaller or bigger.
Well, no, we did include, as part of the, this is actually a smaller model, and we did also include the number of followers, which also was significant.
Yes.
It's not, I mean, it was a very small coefficient, but it was significant. The number of followers that person has increases it. There was another finding that was also significant, which was that the lower the number of seconds it took for the tweet to get to its fifth retweet, the more likely it was to be propagated virally. So the quicker people interact with it, the more likely it is to go viral. Sorry, there's one at the back. He's been printed down those.
I just wondered whether, on some level, you're treating typology as being orthogonal to language. So in a sense, you apply the word net uniformly across the whole topology. But I wonder whether it's also the case that in certain close-knit nodes within or close-knit communities, cliques within a graph, you would actually get some sort of spontaneous vocabulary and grammar that would lend itself to certain types of speech. I wonder whether that kind of analysis could be done.
Yeah, it's interesting, and we are about to look at that because we're looking at London gangs. So that was actually something that we would expect to see is different types of language. I mean, you're going to have very varied language anyway, probably not particularly following traditional words, but we'd expect to see as well some variance between different gangs. So it would be interesting to see if that is the case, because one of the main issues with that is identifying, you can't always get geolocation, but if you could actually infer the gang from the language, that would be, so you then know roughly where it's geolocated, that would be quite interesting. So that's something we're looking at in our project.
Maybe another explanation for this particular finding in the slide about sign page not being retweeted is perhaps that it simply doesn't have the sort of content, it's a spontaneous expression of emotion. Therefore, implicitly, it's not retweeting is more about informing people of concrete events. Whereas we're trying a particular argument, whereas a spontaneous expression of emotion is not something that one would necessarily want to report. I mean, if one was inclined to do that, it would be the same expression.
Yes, that's true. But it's weird that the sentiment will go the other way. So the same thing holds, I guess, for that as well. Although perhaps you could argue that the sentiment will be reporting positive feelings about something which is more repeatable and broadcastable. But
it's most of what the police immediately utmost positive quality of them. In both cases, they will be reporting specific events. Perhaps particular arguments around the case of media that would account for the So maybe if there's some way of measuring the depth of the content, that could be an interesting progress.
I mean, and that's one thing that we really haven't done much of yet at all, is to look at the content itself. What is the content that is being retweeted? There's a lot more qualitative inspection, I guess, that needs to take place to help kind of explain that, whether there's any kind of uniformity across the tweets or sorry,
so my question is for the tools, the Cosmos tools.
And
so it's kind of supporting two types of research, one is more quantitative and more social type of research. And more manual, as well as more computational and quantitative. Is there any kind of integration between these two quite different methods? And for example, you mentioned coding a few times, people have to come this manually. And the result is easily, are they kind of integrated into the classifier they want to do the results?
We were going to go that way. We wrote reasonably large funding proposal to do that, but it didn't get funded. So that's on hold. But that's essentially, we were going to try and link it in. So you get your data, you're going to try and allow people to build a coding frame, push it out, just crowdsourcing, bring it back in, build models, probably not going into statistical models or anything like that, because there's well-established tools out there. There's pointless integrating everything, but at least getting to the point where you could export the data and it would just plug into MATLAB or SPSS or R or whatever else you wanted to use, so that you've taken all the sting out of doing any kind of data preparation and you just throw it straight into the tools that are out there. Because from what we've spoken to a lot of people that would like to do this kind of stuff, but they just can't get grips with APIs, data cleaning, reprocessing and that kind of stuff. And they're the guys with the theory, and they're the guys that we need to really be able to enable to do this kind of stuff, because they can help make sense of it. The Cohen stuff, for example, I mentioned earlier on, it came from my colleague who you can't do all the data transformation stuff, but he can bring in the explanatory stuff later on, which is why we co-direct Centre to kind of push this thing forward.
So have you looked at Node Excel as an
So Node Excel will visualize networks really, really well. It only runs on Windows, but it doesn't matter really. You can do analysis on there. And there's also Gephi, which is another good tool that does network analysis as well. So Cosmos will export the social network in a format that is compatible with Gephi and Node Excel. So again, we're not trying to do the social network analysis in there, but we're trying to allow you to interrogate the data to see whether there's anything interesting in there. Then you can take it out and do the analysis elsewhere.
The problem is that there's so many code-specific tools, and what we don't have is a pipeline of tools that work together in a way that allows social scientists, for example, to actually do the analysis.
Well, that's essentially what we're trying to achieve here. So you can take a data set, you can plot it geographically, you can select an area geographically, you can do a social network analysis of that. You can select a part of the social network and do a content analysis on that. That's the whole idea in Cosmos, is to incorporate as many high-level transformation tools as possible. We're not going to integrate all the functionality of things like Node, Excel and Gephi because they're already there. But it does allow you to do high-level analysis of using a different pipeline, as you say, a workflow. And well, I mentioned reproducibility before, and the idea going forward is to create a structured document that represents what you've done within Cosmos and the workflow and the approach you've taken, so that it can be rebuilt elsewhere and then someone else can continue that. Any more questions?
Okay.
Awesome questions, they're brilliant, I think it's really helpful.
This coffee and tea, and people can ask more questions.
Okay,
Thanks
very much.